Hello everyone. In this video, we will learn to define and explain the terms limiting reactant and excess reactant. 2. Define the term stoichiometric quantities of reactants. Let us try to understand the concept of limiting reactant with something more tangible. For example, we are in a kitchen and preparing some peanut butter sandwiches. The recipe to prepare one sandwich is to put together 2 slices of bread and 1 tablespoon of peanut butter. We can treat this as a chemical reaction and represent it in the form of a chemical equation. That is, 2 slices of bread combines with 1 tablespoon of peanut butter to form one sandwich. This is a balanced equation, that is, the number of slices of bread and the amount of peanut butter are conserved during the process. Therefore, we can use this equation for stoichiometric calculations like we did in the earlier topic. Let us say that when we looked into the kitchen, we found that there are 16 slices of bread. So let me ask you a question. How many tablespoons of peanut butter is required to use up all 16 slices of bread? According to the balanced equation, we need 1 tablespoon of peanut butter for every 2 slices of bread. We start with 16 slices of bread and multiply it with a conversion factor that has slices of bread in the denominator and tablespoons of peanut butter in the numerator, which is 1 tablespoon of peanut butter per 2 slices of bread. If we do the calculation, we get 8 tablespoons of peanut butter. So, to consume 16 slices of bread, we need 8 tablespoons of peanut butter. These amounts of reactants, that is, 16 slices of bread and 8 tablespoons of peanut butter, are called as stoichiometric quantities of reactants. Stoichiometric quantities of reactants mean we have exactly the correct amounts of reactants that while making the sandwiches, both of the reactants are used up completely. That is, there are no leftovers. But in reality, most of the times, we don't start with stoichiometric quantities of reactants in a reaction mixture. For example, we already know that we have 16 slices of bread, which requires 8 tablespoons of peanut butter. We now look into the kitchen to see how much peanut butter we have. We found out that there is a new jar of peanut butter which consists of 20 tablespoons. Now, pause the video here and try to answer the following questions. As we put together the sandwiches, what starting material, that is bread slices or peanut butter, runs out first? Second, what starting material is left over? Third, what starting material determines or limits the number of sandwiches made? We calculated earlier that to consume 16 slices of bread, we need only 8 tablespoons of peanut butter. However, we have 20 tablespoons of peanut butter. Now, imagine we start making the sandwiches and use up all 16 slices of bread. At this time, we would have used only 8 tablespoons of peanut butter. So, the slices of bread runs out first, and the peanut butter is the leftover. Let us now answer the third question. what starting material determines the number of sandwiches made. If 16 slices of bread are completely used, we can make 8 sandwiches. If we have more than 16 slices of bread, we could have made more sandwiches. Therefore, we can say that the slices of bread determines or limits the number of sandwiches made. The slices of bread is called as limiting reactant because it limits the amount of product formed. And the peanut butter is called as excess reactant because there is some leftover after all the sandwiches are made. Let me again highlight the two important characteristics of limiting reagent. Limiting reagent runs out first in the reaction. That is, the limiting reactant is completely consumed in the reaction. There will not be any leftover. 2. The limiting reagent limits the amount of product formed. That is, the amount of product formed depends on the limiting reactant, not the excess reactant.